numbers, cube roots, fourth roots, any roots you like. For more details on that, you need to go to my notes. They're all in there, keystroke sequence. Real numbers. One final classification of numbers that I want to talk to you about in detail, and that is the concept of a real number. Real numbers are really just a combination of all the rational numbers and all the irrational numbers. The math symbol is this double bar R. Okay? In writing, the symbol's traditionally just written something like this. Okay? So if you had to write down on paper, this is what you would do. And this is the most typical common symbol you'll see. Most of the others, maybe not. Right? But this one almost for sure is an instructor will slip it in class. Be aware of that. Again, a real number is just any number that can be represented on a number line. So earlier we talked about how to represent on a number line a specific integer or a fraction, a rational number, whole number. How can we represent all the real numbers? Well, that's easy. Just go ahead and shade in the entire number line. Just make it like a figure line. That's all you got to do. Now that we've covered all the basic types of numbers, there really is one more thing we should worry about. As well, what if something isn't on a number line? Ugh. You know, it's great to have a point, right there on a number line, but what if my point is now, well, there? It's not on a number line. Then what? That's a good question. Well, in that case, we have what are called imaginary numbers. And they're represented by a lowercase I, like this. The imaginary numbers are numbers that are not real. But that's okay with it. If you have a hard time understanding what an imaginary number is, don't worry about it too much. I have an entire different lesson that all we deal with are these imaginary numbers. If we combine this imaginary numbers with the real numbers, then that is what we're going to call complex numbers. The symbol for complex numbers. Again, I don't talk about complex numbers in detail in these notes. Again, I'd say for another lecture. But I want you to be aware of their existence. Another example of a complex number is very specific square roots. For example, the square root of -2. For example, I cannot put that number on a number line. It's not real. The inside, or the radicand, of a square root must be positive or 0. It cannot be negative. Negative, we can't do anything with it. Those are part of the imaginary numbers. I mentioned this, and I mentioned about the eyes, because sometimes on exams, a professor will give you a list of numbers and say, which one of these are real? And, well, you can be able to identify, oh, if I see a square root of a negative number, that negative's on the inside, I can't count that. Right? Or an I. If I see like a little lowercase I on the outside, all bets are off.